Okay, this is part 2 for the Unit 5 review. This is going to be the calculator portion. So again, the Unit 5 test is going to be broken up into a calculator and non-calculator section, and it's going to cover the area, volume, including discs and washers, and also cross-sections and arc length. So on this one, it's asking about the arc length. Now, the arc length questions could be calculator or non-calculator. So here's one where they actually asked you to solve it using the calculator. So it says find the arc length of the curve y equals x to the fourth between 2 and 6. So remember, your arc length formula is going to be the integral from left to right, and it's the square root of 1 plus the derivative squared with respect to x. And so what I first did is I took this y equals x to the fourth, and I took the derivative. And then I'm going to take that derivative, right, and I'm going to plug it in right here, but you need to make sure you square it. So this is going to be the integral from 2 to 6, and then really this is a and a b here. So the integral from 2 to 6, and then the square root of 1 plus, and I just took this derivative and I plugged it in. Be careful on the algebra here. So this squared has to apply to both of the 4 and the x cubed. So you get to here. This would be an example of where it might be if it was a non-calculator question. It might stop right there, and that would be an answer choice. I do know that they would probably forget to square it as one of the incorrect answer choices. So just make sure you're doing that. And then via Math 9, since this was a calculator question, you could kind of type that in. So I just did Math 9, and we're going to go from 2 to 6. And it was the square root of 1 plus 16x raised to the 6th dx. And we're going to type that in, and you get that number, which is choice A. So you've got that one as A. All right, moving on. The next question is from the 2005 AB exam. It was actually on the Form B, so maybe it was the international one. And so they give us both equations here, and they actually give you the picture, which is nice. They give you the graph. And pretty typical question. You could see in Part A they're asking for area, then they're going to volume when you're revolving around the x, and then they're going for a volume with a cross-section. So this is a really good example. I'll grab how many points each part of this is worth. But let's kind of get started here. The first thing I did in this problem, I'm going to go ahead and type those into my y equals. So I just typed those in. And then I'm going to graph them, even though they kind of gave me the graph. I wanted to see what was going on myself. Because I know that when I'm finding the area, I'm going to do area is top minus bottom from left to right. So I'm going to be very concerned about these x values there, because I'm going to need those for my bounds of integration. So to get those, you'd hit second, calc, intersect, that's choice 5. Pretty sure that one's 0 over there, but I want to get close to my intersection, so you kind of use your cursor. You're going to hit enter 3 times, and then it's going to give you that the intersection there, and that's 1.1356 there. So I'm going to kind of make a note of that. So I know that that's going to be 1.135692.5. Make sure you don't get too round happy here. You want to make sure that you're using all the decimals needed. You don't round to the very end of the problem. So I made a note of that x value. And you know what? I have the y value right there on my screen, so I'm going to go ahead and write down that y value of 1.76446628, just in case I need it. Okay, so let's set up my area first. So I'll do in part A. So we have the area. It's going to be the integration from 0 to that 1.1356925. And then it's going to be top minus bottom. On the AP exam, you can write out f of x minus g of x. You do not have to go and write those in, or you can. And then I'm going to use my calculator to help me find this, since it is a calculator active question. So I'm going to do Math 9. Oops, I got to get it back to my home screen, sorry. So we've got Math 9, okay, and I'm going from 0, and if you could have checked that 0 if you weren't sure about it too. 1, 5, And again, don't get round happy. Notice that I'm using the entire decimal here. Okay, and this is the part where your calculator can really help you out so you don't have to type in that 1 plus sine 2x minus, right? You can use the vars key. So I'm going to go ahead and say I'm going to do vars, slide over to y vars function, and I have it's my y1 minus vars again, y vars function y2, and I'm going to integrate that with respect to x, and hopefully that'll spit back my answer. Now is where I'm going to round to 3 decimal points. So I've got my setup. Oops, bad notation here. I need a dx. And again, via my calculator from Math 9, I got that to be 0.429. And that is part A. And if you got all that, then that was worth 3 points, because A, B, and C were each worth 3 points, basically according to the scoring guide. There was a little bit of leeway. If you missed something in part A, you could have earned another point, but overall basically 3 points each. So if you had the bounds of integration, the setup, and the answer there, you'd get your 3 points. So 3, 3, 3. Okay, so then let's take a look at part B. Part B then says we are going to find the volume when we take this and we're revolving it around the x-axis. So this is my shaded region R, and we're going around the x-axis, okay? So I always kind of start by classifying it, and I'm like, okay, my axis of revolution is a horizontal line, and there's going to be a gap. See this huge gap here between the highlighted region and the axis of revolution, so it's going to be a washer. So I just kind of make myself that note. So I'm like, this is a washer. It has a horizontal axis of revolution. That tells me that I need to be thinking in dx, okay? So I know that for volume with a washer, my formula, volume, is going to be pi, the integral, from left to right again. So I'm going to use those same numbers. So it's that 0 and that 1.1356925 number. Okay. And then it's a washer, so it's going to be quantity squared minus another quantity squared. So this is like your big R squared minus little r squared dx. So when I visualize this, I say that it's going to be the outside curve minus the axis of revolution. Now here it's nice because the axis of revolution happens to be 0. So really this is the f of x minus 0, that's the outside, minus the inside curve is that g of x minus 0. And again, if you wanted to write out the f of x and g of x, you could, but this is just a little shorter. So there's my setup. And again, this is a calculator question, so you're going to be using your calculator. Please don't forget to multiply by that pi on the outside. That's a good way to kind of lose a point there. So I've got that, and I'm just going to go back to my calculator. Again, those are still stored in my y1. So my f of x is my y1. My g of x is y2. So when I go to integrate, I'm going to do Math 9 again. Okay. And I'm going to do 0, 1.1356925. And so I'm going to use some parentheses here. So I'm going to do vars, y vars function, and then it's choice 1. So it's that thing, close it squared, minus, and then another set of parentheses, vars, arrow over, and we're going to do y2 this time, close that squared, and we're integrating with respect to x again. So I kind of checked that. That all looks good. Take a second on the AP exam and make sure. You don't want to get something wrong for typing it incorrectly. So my calculator thinks that, but then don't forget you need to multiply that by pi. So I kind of do that. It's very easy to do that. And then that times pi. So we'll do it like that. So yeah, my final answer is going to be that 4.26 and 7, it looks like. Perfect. Okay, so again, that would have been worth 3 points as well. All right, let's take a look at the final one, part C. The region R is the base of the solid. We're doing cross sections perpendicular to the x. That makes me happy again. I'm thinking I'm in dx. I don't have to solve anything. Now we're using semicircles with diameters extending from f of x to g of x. Okay, so that's the whole diameter. Find the volume. So it's just a volume by cross-section. I wish I would have written a little bit smaller, but all right, part C, here we go. So kind of go back up to the picture here. So now my cross-section that I'm dropping in is going to be like this, and there's going to be a semicircle popping up from the paper. It's hard to see in 2D there. So the diameter here, to find the length of the diameter for that semicircle, we're going to have to do f of x minus g of x, but then cut it in half, because remember, that's the diameter. So if we want the radius, and we're going to need the radius for the formula, we'll have to cut the diameter in half. So we'll kind of scooch up here. So I'm going to kind of start by saying the area, right, of a semicircle, and we're going to the x-axis, so it's with respect to x. Ooh, that doesn't look like a semicircle. But that's going to be pi r squared over 2. And so for this problem, I'm just going to leave that pi over 2 out there. The radius squared, we're saying, is going to be f of x minus g of x, but we have to cut that in half in order to get to the radius. Then we're going to square it. So you've got that. And to then go to volume, okay, so then volume is going to be the integration of the area. So I'm going to take this part and pop it out front. So I'm going to have that pi over 2. And then we'll have that f of x minus g of x over 2 quantity squared. Okay, and that's with respect to x. And we're going to be using those same bounds of integration that we had before. So that's 0. I can't really fit it, but I'm just going to write that. Again, I'm using the whole number. I'm just kind of writing it there for shorthand. So you're going to go ahead and put that into your calculator. Okay, so you put that in your calculator. Make sure you square it. So when I type that in, this is what I got. And then don't forget, I still have that pi over 2 out front. So now I need to multiply that answer by pi over 2. So I'm going to do that. And I get that 0.078 then as my very final answer. Okay. Again, those were each worth 3 points. So you can kind of see how you would have done on the AP exam for that question. Okay, this is still a calculator question. This is from 2008. So we're going to say let R be the region bounded by those two graphs. We're going to find the area first. So the first thing I would do is put those into my calculator. So just in your y equals, I would go ahead and put that, and I'm going to call that my y1, and I put this one into y2, and then I graphed it. You can adjust your window so that it fits. So I'm kind of looking at the same picture as they gave me, and now I'm going to be finding the area. So to find the area, let's see, we'll do part A. By the way, this was worth 3 points and then 2 points for each of the next parts. So to find the area, we are going to do top minus bottom from left to right. So you could see here on mine, it's the blue curve, or that sine curve, which is my y1. So we're going to say area is going to be the integral of that y1, or I'll say y1 minus y2 since I labeled mine up there, okay, from left to right, and we're going to integrate that with respect to x. And we need to find then those bounds of integration. So we're going to go ahead and do that by doing second calc intersect. So second calc intersect, we need to figure out, right where those two are meeting. So I hit that 3 times, and they intersect right at 2, okay? I wasn't sure if it was right at 2, but so we're going to go from 0 to 2, and you can confirm the 0 by doing the same thing, second calc intersect. And then we need to do a math 9 here, so we'll do math 9. I'm going to go from 0 to 2, and then I have mine in my vars, so y vars, so y1 minus, and then I'm going to get my y2. And again, you could type them in there. I just think this is easier. And we're integrating with respect to x. And I get 4. What a nice answer. Okay, so my answer to part A there is 4, and that was worth 3 points. All right, now it says the horizontal line y equals negative 2 splits it into 2 parts. Write but do not evaluate the expression for the area that's below the horizontal line. Okay, so for part B, well, the first thing I would probably do is go back here into my y equals. And now I'm going to throw an additional line. I'm going to do -2 in there, right? It said -2, so I'll graph that in there. And then if R was this whole thing, right, now my new part is just this part down there, okay? So I'm just looking at this chunk. So I'm still trying to find an area, okay? So I'm still trying to find an area. So the area of this, I'm still going to have to integrate top minus bottom. Well, the top is going to be that line -2. So it's going to be -2 minus the bottom. That's the red curve for me. So that's going to be my y2. So minus y2 with respect to x. Now here might be the tricky part. I need bounds of integration. So I need to figure out what is this point right there. What is that? I'm sorry, not the point. What is the x value right there? And also what is the x value right here? Okay. So I'm going to have to do that by doing second calc intersect. Okay. So I'm going to do second calc intersect. But this time I'm concerned about where this black line crosses the red line. You might need to kind of arrow over a little bit to make sure that you're, where you want to be. So like right now my calculator's on that blue line. I want to be on the red line. So I need to get over till it jumps to that red line. And if you have problems getting that to do, you can always go back to your y equals and take out, or you could kind of turn off that blue curve if you kind of can't get it to graph in there. So I might do that just so that I make sure I get the right intersection. Still have that. Okay, so now I'm going to do second calc intersect, enter, enter, enter. So my right bounds is going to be that 1 point. So here it's going to be 1.6751309. Okay. And then I need to get the other one. So second calc intersect again. So I need to go over here. So there's that and that. And the first one then is 0.5391. And it's like 8887. Okay? So I kind of have those. Now that I got those jotted down, now I can go back to my home screen and I can do math 9. Oh, no, it said set up and do not evaluate. So that's all I need to do there. So you can do that one for that. Okay? And then that was worth 2 points. Now I'm on to part C. Okay, because it said set up but do not evaluate, so I'm good there. All right, part C. The region is the base, so cross sections perpendicular to the x. So I see cross section, x-axis, so I'm thinking it's going to be a dx problem. Okay, and it's a square. So that means that, you're dropping in all these different cross sections like this, right? They're all squares. And so I need to find the area of a square first. So we know that the area of a square, right, with respect to x, because I'm perpendicular to x, is going to be side squared. So in my drawing here, or in my sketch, the side length is going to be this top curve minus the bottom curve. So again, that's my y1 minus y2. I almost like it better when they call it f of x and g of x, but for me that's going to be my y1 minus y2. Okay, that's going to be that. So that's the s, and I need to square it. And then volume is going to be the integration of area. So I need to integrate that with respect to x. And now I need my bounds of integration. Oh, well, that's going to be from left to right, so that's just that 0 to 2. And you could type that into your calculator again. So we're just going to go back to that home screen. Oh, I still got that on there. What a happy coincidence. So 0 to 2. And for me, it's going to be y1. Oh, I need to put in a parenthesis there because I need to square it. So y1 minus y2. close that up and square it and integrate that with respect to x from 0 to 2. Make sure I typed everything in correctly. And I get that number, and I'm just going to round that to 3 decimals. So that gives me what? 9.978 for my area there, or for the, my volume there using cross sections that are squares. Okay? So I thought that those 7 points were pretty good. And then we go on to part D. What does part D say here? So we have a area, it's the base of, or it's the surface of a small pond, okay? And we have that being the distance, okay? The depth of the water is given by this. Find the volume of the water of the pond. So this one I think is a little trickier. We're going to say part D here, okay? So really the volume of any object, okay, is the area of the base times the height. And so that's how we're going to kind of attack this one, okay? So volume is going to be the area of the base times the height. Well, the area of the base, we kind of have that set up going on up here, and we'll just need to multiply that by the height, and we're going to have to integrate it from 0 to 2. So we're going to go from 0 to 2, and then we're going to say it's going to be y1 minus y2, so there's the area of the base, times the height. So they're telling me in this problem that the height is this 3 minus x, and we're going to integrate that with respect to x. So that's how I would put it in, and then we're going to type that into the calculator. That might take me just a second here. So let's see. Okay, so math 9, we're going to go from 0 to 2, and then we can type that in and see what we get. Okay, so that's what I typed in, and then I got that 8.30, that'll be 70 number, okay, because if you round to 3 decimals, you get to there, okay? So that was all of that problem. Okay, the last one we have here is from 2004. So I got a little head start here. I kind of sketched it out where it's a very pretty straightforward area and volume problem. So I graphed the square root curve shifted to the right one. You have the line x equals 10 here, and we have the area bounded by that in the x-axis. So here's your shaded region. The area, so remember area is the integral from left to right, so that's from 1 to 10. And then it's going to be top minus bottom, and that's a dx. And you could put that right into your calculator for math 9, and we got an answer of 18 there. Okay, so then next up, for the volume, it says that we are now going to spin this around the horizontal line, y equals 3. So again, this was a calculator active question, so I would go there, and I would maybe even just graph in y equals 3 just to see what it looks like with it. But I know that volume, when we're revolving, is going to be pi times the integral, okay? And we're concerned with where those cross. I might need to adjust my window a little bit. I need my y maximum to be like 5 instead, so I can see a little bit better there. So since I'm revolving around a horizontal line for part B, it says the line there, it's a horizontal, so that means it's going to be a dx. So I need to see, is there a gap between there, okay? So we would notice if you wanted to do that second calc intersect, just because you weren't sure, so second calc intersect, we want to know where those two cross, and they do cross exactly at 10. So if you were trying to kind of sketch this in there, okay, when that's revolved around the line, y equals 3. So because there's not a complete flush thing, the area that we're revolving is not flush, this is going to be a washer. So we're still going to integrate from 1 to 10, okay? But now it's going to be a washer. When it's a washer, we're going to have two sets of parentheses, okay? And it's going to be a dx, we said. So we've got pi, the integral from 1 to 10, and we're going to do the outside minus the axis of revolution. So the outside is actually the curve on y equals 0. So it's going to be 0 minus the axis of revolution is 3, and then minus the inside curve, which is square root of x minus 1 minus the axis of revolution, like that. So there's kind of your setup. You can clean that up if you wanted to, so this would be something like 9 minus, and then I would probably just even leave this. It's not worth making an algebra mistake. So you can go and plug that in via Math 9 on your calculator, and let's see what we get there. So you type that into your calculator, and I got that 67.5 number. Don't forget to go back and multiply that by this pi. So my final answer for part B is this 212.058. And then we go to part C. Alright, so part C is a little trickier because now we're revolving around this vertical line here. So we're still taking this same section, but now we're spinning it around here, so it's going to be a dy problem, okay? Which means I then need to solve this for x before I can kind of do that. So I'm going to start by squaring both sides. So I get x minus 1, and then I'm going to add 1. So you end up with y squared plus 1 equals x, okay? So now I have that solved for x. So we're going to say the volume, still going to be a pi. We're going to integrate, and now, since it's going to be a dy problem, I go from bottom to top. So,
can you help me?
Okay, so we're going to integrate from 0 to 3, because those have to be y values. Remember, we already found out that this was a 3. And then we're going to integrate, it's going to be a disk, because when we flip this thing, okay, when we start revolving that, it's completely flush against the axis of revolution. So we're just going to have one quantity squared, okay, and it's going to be a dy. So we need to use this equation up here, okay, and then we can do that to kind of get that before you put it into your Math 9. Okay, so it's going to be y squared plus 1 minus the axis of revolution is 10, close that, quantity squared dy. So I know some students get stressed out about this, like, oh, I can't put that in my calculator. Well, you can. You're just literally going to use x's instead of y's. As long as these are y values, these are y variables, and this is, those are all the same, that's what you're doing. So you put that into your calculator, and I got that 129 number, but then don't forget to multiply your answer by pi. So my final answer is going to be 407.150. And that's how you'd get all your points for the 2004 one. Have a great day. Good luck on your test.